Hi, welcome to CSE114 Introduction to Object-Oriented Programming, and here we are starting a new chapter where we will look at a class that provides a lot of functions for us or the methods for us which we can use for doing some mathematical operations. So in this lecture we'll go over some mathematical operations, some methods which are available in a class. We'll learn about that class, and then we will also spend some time looking at characters, and finally we will cover the topic of strings. Okay, so let's start the discussion with the concept of static methods. So you have been declaring your main method as static. So for us, the header for the main method has been like this. Always we declare main as static. So you'll get some idea behind this fact that why do we declare a main method as static. So there are uh, two kinds of methods, I would say, at this level. Static and non-static. So non-static is also called instance, right? So let me use this space to discuss the difference between methods. Well, the same applies to class variables as well, but since we are not doing instance variables or class variables for the time being, so let's confine our discussion to methods only. So you can have methods, two categories of methods. One where you will be using static keyword, right? So they are called static methods. And then you can have the second category where you will not use the keyword static, and those methods are called instance methods. Okay, so here as an example we did write one method. So whatever we have done, we have been writing this main method. Okay, and the main method that we have written is static in nature. Alright, so how do we declare a static method? We know about that, right? So main method we have is declared as static. So it was public. We know the meaning of public. Public means that it can be accessed. This method being public can be accessed from any class if you want to. But main method we may not like to call, because calling this main method from a different class will not make any sense to us. But if in place of main method, if we had some other name for this method, then being public, you could call that method non-main method from a different class. Okay, why? Because this is public. We don't impose any restriction on that. Okay, so private is another access modifier which we'll learn about, but we have been dealing with public till now. So I will assume that you understand what public is. Public means this method that you're declaring can be accessed from outside the class also. Now in the next couple of slides, I will try my best to explain to you this concept of static. So when you call some method as static, then what does that mean? Okay, so let me give you some more examples. So main was a static method, right, which we have written. Let's think about those methods which are already written in Java, and these methods we use. Right, so let's look at the category of static method. I can give you one more example. So this is main method, right? So there's one more example of static method, which is println. So how do you call println? To call the println method, we do something like that. We say system dot out dot println, and then whatever you want to print, that goes in this method. So this println method that you have is static. Alright, so now let's try to have some understanding of what do we mean by static methods. So whenever you have to invoke a static method, this is called invoking. You are calling println method. This will be a declaration. Right here you are declaring your main method, whereas right here you are invoking the println method. So if you want, I can put that here. We are invoking. Invoking means we are calling. We are calling the println method, which exists in system class. Right, so there is a class called system, and that system we have an object out, and in that object we have a method called println. So println is a static method. Okay, cool. So now let's have a look at the non-static, right? Then we will understand the difference between static and non-static. So static methods, if you have to invoke, let me write that here. For static methods, we don't need an object. Need an object of the type of that class type. Okay, so what you did whenever you said system.out.println, you did not create any object for the system class. Alright, we did not create any object for the system class, and in place of that we straight away mentioned the name of the class. What is it? This is the name of the class name. Okay, so if we are calling a method by just with the help of the class name, then that method would belong to the class of static. Right, so for static methods we don't need an object for the class type, and similarly we call methods, static methods, with the help of the class name. Okay, so if you have to let me add one more point. If you have to call a method which is static but it is outside your class, right, then you can access that method by using the name of the class in which that method exists. Okay, so you had done system.out.println because this println method is in system class. Okay, alright, so let me give you one more example. Okay, so this is about static. Now let's think about non-static thing, like how is the life different in non-static. So for non-static, or which I'll say for non-static or instance methods, we need to create an object first. Alright, so you would ask me, for example, so how about string? Right, so string is a class, and we have been doing something like this. Okay, we did not, but anyway we will do that in this lecture. But string is such example where if you have to use the methods which are defined in a string class, then you first need to create a string object. Let's discuss something which we have done already. Scanner class, right? So what you did whenever you had to use a scanner method, a method which is defined in scanner class, you will do scanner, you will do stdin, and what was stdin was an object that you were creating. You'll say scanner stdin is equal to new, then you will say scanner, and then you will put system.in, alright, semicolon here. So after that, what happened, this is an object which you created, and then only you can invoke the method like this. You'll say std in dot next int. Okay, let me fix that. Alright, so here, a second, it doesn't look good. Okay, so you needed an object which is stdin, and after creating that object only, you could invoke a method like next int. So that is the difference. Okay, for instance on non-static methods, you first need to create an object for that class in which these methods have been declared. So as an example, scanner, right? So as the next int method that you might use from the scanner class to accept the input from the user, you will have to first create an object of the scanner class, right? Only after using that object name you could access the methods which are there in the scanner class. Whereas for static classes, you don't need to create any object. You can access the methods which are static in the nature from that class directly with the help of the class name. So that is something we will be doing heavily in this lecture, at least in the initial part. So I thought I should give you some idea about it. Don't worry, we will anyway discuss this static and instance thing when we get to object oriented programming. But this much of background would be helpful to you for you. Let me know if you have any questions. Okay, so fine. Now this class that we will be learning initially, most of the methods are static. Okay, so let's look at it, right? Let me see what do I have in my lecture notes. So what is a static, right? So in static, a method, right? A method would be called static when we associate a method with the particular class name, which means that if you have to invoke that method, then invoke that method with the help of the class name. All right. Now, any method can call a static method when if you are directly in that class. So in our example, this is what we have been doing. So when you wrote main method, then your main method had been static, and this main method you are calling from that class itself. Similarly, when we will learn about methods, or methods should be static initially, and then when we discuss object oriented programming, then you will see that most of the methods that we will write, they would be non-static in nature. So if you have written a static method in a class, then you can access that directly inside that class without mentioning the class name. But if you have to use that class from if you have to use that static method from outside the class, then you'll have to use the class name. Alright, now all these things will make a lot of sense once we start working on a class in which most of the methods are static in nature. Alright, so I'm referring to the math class. Okay, so this math class is very important because it has some data members, or the constants I'll say, which we might need in some mathematical computations, and then it has bunch of methods in there. So let's start looking at the constants. So this pi is 3.14. The value that you will need, I don't remember the remaining digits, so 3.14 and so on. So you may not remember, right? It's very difficult to remember the full pi values. So you don't need to worry. What you will have to do is just remember that in math class we have a constant called pi, and this pi is the same as this pi, and you'll get the exact value of the pi if you need to. But there is a trick. Okay, you cannot use pi directly since this pi has been defined in the math class and this pi is static. So how do you invoke that? If you have to access pi, you should mention the name of the class, which is math, and then pi, that is in capital. All right. Similarly, we have e. This is the base of natural logarithms. I don't exactly remember the value, but I think it is 2.78. I will correct that if that is wrong, right? Please double check. But you don't need to remember. If you need to use E for your program, you can easily refer that by calling it with the name of the class math.e. Okay, so something that you should straight away get is the way we are accessing pi and e. In order to access pi and e, which are the constants that are defined in math class, we need to specify that they belong to the math class. Alright, so you will say math.pi, math.e. So for most of the stuff that we are learning about math class, you have to access those with the help of the name of the class, which is math. Okay, so now we will look at some very important methods which are available in math class. We can classify them into these categories like trigonometric methods. Sometimes you might need to use sine of an angle, cosine of an angle, tangent, so on and so forth. So for all those cases, for all those computation, we have some methods which are available in the math class belonging to trigonometric category. Similarly, we have some methods for exponent computation, like if you want to do a raised to the power b, how can you do that? If you want to compute log of x, how to do that? Alright, so yeah, we do have some methods in the exponent category in the math class, which will help us in doing this, in computing these things. Then there are some rounding methods. If you want to round the number for some reason, then we have the min, max, and absolute methods as well. So these are self-explanatory. I will use some examples to show you how these will work. Then the most important method that we will learn is a random method. Okay, so I mean, this is one of my favorite topic, and you should expect a lot of questions on random method. I won't say that write a program for random thing. I will ask a question which involves the use of generating random characters, random strings, or maybe random number. So all those things boil down to this method called random, which exists in math class. Alright, so let's see what do we have here. So for trigonometric methods, we have a method like sine, cosine, tangent. So all these methods will compute the sine of the angle, cosine of the angle, tangent of the angle, if you provide those angles as the parameters. Okay, so this value that it expects are in double, so make sure that if you pass that on in integer, anyway that will be converted to double. So integer is not a problem, but yes, it should be numerical value. All right, this is something which you need to keep in mind. The value that you are giving to the sine, cosine, and tangent function, these angles should be in radians. All right, if if you are passing on some value like 90 degrees, right, then you'll get some strange result. So what I should do right here is, let me do a demo for you regarding trigonometric methods. Okay, we'll discard the things that I've written. I'll use the demo or program that I had written. If you want, well, let's create a scanner object. Scanner stdin is equal to new scanner and system.n. Alright, so again I can put some note for you. Okay, later in the next line I'll do that. Let's prompt the user, enter an angle value. Angle Okay, so double angle is equal to std in dot next double. Okay, so here I should say that we are calling invoking an instance method. Instance means non-static, right? Why is this instance? Because you're using an object. stdin is an object, so if you need that, I will say declare an object stdin for scanner class. For scanner class or of the type scanner class, that means the same thing. All right, so what do? We got the value, right? So the user will give some input, which should be a double or an integer. That will be all right. We are saving that in a variable called angle. Now let's compute some value. Well, trig value. I'm calling it trigonometric value, trig value, because I will be using it for different kind of functions. So how should I call this? You have to call math dot what is it? Math dot sine. Let me compute sine of this value, which is angle, and then I should print out, I should say that sine of angle. Now you should write the angle is okay, and then let's use trig value. I'm deliberately ignoring one fact, which I will explain to you with the help of an error. Control Z, messed it up. Dot close. So I remember a student mentioned to me in an email, I think today itself, which was about the fact that compiler complains if you don't do this thing, right? If you don't close the scanner object, then this guy is not happy. It will say that resource leak stdin is never closed. So that's fine. If you want to run it, will still work. But if you don't like to see warnings the way I am, then I would like to close it towards the end of my program. Alright, now compiler is happy, not raising any alarm. Okay, good. So well, let me say invoking a static method. Right, so see the difference. Say the difference between between the invocation on line number 6 and line number 7. Next double is a method. Okay, so is sine. I should use sine. Okay, I don't want arc sine. I just want sine of that angle. All right, so on the line number 7, I want to compute the sine of an angle which the user will give. So I'm calling sine method. And the line on number 6, I'm invoking a method so that I can receive some input from the user through the keyboard. And I want an angle value. So the difference between the line number 6 and 7 is that in the line of number 6, I'm invoking an instance method. Whereas in case of line number 7, I'm invoking a static method. So for static method, I'm using the name of the class, which is math. In the case of line 6, I'm invoking an instance method. So I'm calling that with the help of an object. All right. So that's the difference. Okay. You need to have an object if you need to invoke an instance method, whereas for static method you don't need any object. You can call that with the help of the class name. All right, so let's run that. Okay, and Let's see. Enter an angle value. So I don't know. Well, I would assume that you remember at least the sign of some common angles like 90 degrees. You should know that. Sine of 45 degrees. You should know that, although it is not required. You are not supposed to remember these values for CSE 114, but I'll assume that you know. Okay, so let's see. If I say that find out the sine of angle 90, what did we get? Is this correct? Why you should know the sine of 90 degrees is for this reason. Is it correct? Answer is no. Sine of 90 degree is 1. Alright, let's try one more thing. Let's put 30 degrees. I don't remember for 30 degrees. Alright, so negative. I know for sure that sine of 30 degree is not negative. Now you should wonder, why is it happening? Well, it is happening for the reason that the angles that you pass on to the sine method has to be in radians. Okay, so 30 degrees and 90 degrees will not work. What we need to do is we need to convert this angle into radians. Alright, back to your lecture slide. The argument that is being passed is assumed to be in radians. So it is your responsibility to convert that angle value into radians. Alright, luckily for us, we have a method called 2 radians, which will convert the degree value of the angle to the radians. So that's what I will do now. What should I do? I will change this. I'll say math m with capital. Okay, math with m capital, math dot 2 radians, and here control X. Okay, so what did I do? I changed the angle which the user is giving in degrees to the radians, and now it should work fine. Alright, so let's run that. I should start with 90. Yeah, you got the correct value, which is 1. So please remember these finer details. If I say 30, I'm expecting 0.5 if I correctly remember. Okay, approximately 0.5. Okay, 0 0.4 or 0 0.499999, which I'll consider as 0.5. Okay, so I hope this will help. Please do all these exercises. Things are very simple in this lecture. The only thing which I expect, which you should work on, is remember that the math class has all these useful functions for us to use. So remember 2 radian method, because you need to convert the angle that the user is giving to you in degrees to the radians. And similarly, we have the 2 degrees as well. So if you have some angle value that is in radians and you want to get it back in degrees, because I believe that human being, they understand degrees better than radians. At least to me that is the case. So if you want to convert some value which is there in radians, then make use of 2 degrees method. Okay, good. So now let's discuss about the last 3 methods in this category. A cos is the inverse of the cosine method. So if you know the cosine of an angle and you want to know what is the angle value that corresponds to this cosine value, then you should make use of the method A cos. Similarly, you should use A sine when you know the sine of an angle and you want to find out the corresponding angle whose sine is known to you. Similarly, we have the inverse of tangent method as well. Now there are some examples which I'll say that you should try. Okay, and yes, I hope you won't you won't have surprises there. Well, I'll use pens. So here, what has happened in these examples. So when we are saying math.pi, right? So that means well, some you need some mathematics background. So pi radian is equal to 180 degrees. Alright, so 90 degree is also called pi by 2. Pi by 2 is 90 degrees. And when you're saying pi by 6, that means pi by 6 is equal to 30 degrees. Alright, so either you can do it the way I did by getting the value of the angle in degrees and then invoking the method, which is math.toRadians, or you can convert that directly into radians. So for 30 degrees you should call that math.pi, because this pi that you have is declared in math, right? We have a pi constant which is the same as this pi. You can divide that by 6, which will be 30 degrees. Okay, so the same thing is used here also. Math.pi by 2 means 90 degrees. Math.cos 0 is 1. 0, whether you write that in degrees or radians, is the same thing. Okay, so please try all these things. Very simple. Now let's look at the exponent method. This is a different category. In the previous slide we looked at trigonometric methods. Now let's look at exponent methods. So in that exponent method we have the very first method, which will compute something like e raised to the power x. X could be a value that you pass on. Alright, so wait a second. Okay, I think that is deleted. I said 2.7 and 8 as far as I remember. Then e is 2.71. I apologize for that. So when you say exp1, that means you are saying e to the power 1. So you can get that value by calling math.exp1, which will return 2.71. If you want, you can compute the log of a value as well. For that you'll have to call the method with math.log. Okay, so this math is often ignored. I've seen that in the past, that even I miss it out, and a lot of students, they miss this thing. And if you're missing it, then that is wrong. You will lose points for calling a method without using math, if that method is in math class. Alright, so you can compute the log. Okay, so if you do math.log 2.71, you should get 1. Okay, yeah. So log 10, well, here it's called natural log, because here the base is e. When we say natural logarithms, that means our base is e. When we say base 10, then that's a different thing. A base e and base 10 is totally different. So we should be careful about it. Do we want to compute the natural log? For natural log, you should call this method log. And if you want to compute the log when the base is 10, then call log 10. Alright, so it is 10 base, whereas the previous one is e based. Power is a very common method which you might use in your programs. So this power function takes two arguments, which is a and b, and it will raise a to the power b. Okay, so the first thing is to be raised to the power that you have in the second argument. It will compute a raised to the power b. So if you say math.power 3 2, it means that you are computing 3 square, which is 9. Alright, and similarly you have square root function, square root method I should be saying, in Java, which implements the square root function in mathematics. Okay, so if you want to find the square root of 4, then you should say math.sqrt 4, which will return you 2. Let me do this thing actually, because I don't like the fact that I gave you the wrong value of e. We'll discard this and let's go back to the demo. Okay, I don't need any input from the user for this demo. That's simple. So value of E is, let's find that out. How do you get that? Math.exp and 1. All right. 2.718, I forgot one. Yeah, 2.718. So you don't need to memorize these things. If you are doing programming, I don't know about mathematics though. So for programming, if you have to use E in your program somewhere, then you can either do it this way or there's another way. What's the other way? Well, how about this? Math.E. Okay, E is also a constant, right? So no surprise, I should get the same values. So you should wonder, like, why do we have this method exp? Well, you have this method so that if you want to compute it, say square, you want to do E square, right? So these things are very common. Now you're getting the square of that. So exp is a method which will raise E to some power. Alright, so E is to be raised to some power, and if you have to do that, you should call exp. And for general power thing, you will have to use the method power. Alright, let's move on. Now we are going to the third category of methods which are available in math class. Rounding methods. So it depends. You might want to round the value that you are getting, and rounding makes sense when we are talking about decimal values. Okay, so decimal values means either double or float. For integer, you would never round because integer is an integer, right? Whereas if you have values like this, 2.9, oh sorry, if you have 2.999, then you might like that to be rounded to 2.999. You may not like that to be rounded to 3. Okay, it's possible, right? So for these rounding, you may like to round it in different ways. So for that, we have different rounding methods available in Java. So let's look at the ceiling function or ceiling method. What does it do? So ceiling is, in mathematics, we have this operator for ceiling. Alright, this way we write ceiling. And for floor, we have this operator. Alright, so if you have 2.9999 and you're doing ceiling, then surprisingly the value that you will be getting even in mathematics is 2.0. It rounds it down. Alright, and how about seal? Seal means it rounds up. Okay, so anyway, this has to be 3 by general rounding also. But in place of that, if you had something like this 2.00001 and you call the method seal, then from mathematics concept also, ceiling of 2.00001 is 3. That means we round that double value, we round the decimal value to the next integer, right? Round up, you increase. So if it was 2 and there's some fractional value, there should be some fractional value after that. It could be very, very small. So in ceiling, you have to round up. Round up means if it was 2, make it 3. And what is floor? Floor means you round it down. That means 2 point whatever it was, whether it was 2.0001 or 2.9999, in both the cases it has to go down. You are rounding down to its nearest integer. In ceiling, you round it up to the nearest integer. Round up and round down. This is something you need to remember. Okay, how do we call that? Well, math.seal. Math.seal of 2.001. Alright, and similarly you should say math.floor of 2.99999. Okay, good. So now the third one is an interesting method which is called RINT. So what this RINT does, it will look at the value that you want to round. Okay, so interesting thing is that if you have an option, if you want to round, if you want to do RINT, you want to round by calling this method RINT, then it will do some interesting stuff for you. Let's think about some case. So we have two options, 2.5 and 3.5. So what RINT does is that in these two examples, these are different examples. Okay, I did not say 2.75, I said 2.5. I did not say 3.25, I said 3.5. So what is common in these two values? If you have this is scale. All right, if you have this scale, and in the scale you have values like 1, 2, 3, 4 and 5. Let me draw a line. 3, 4 and 5. Now 2.5 is in the between, just in the middle of 2 and 3. Okay, it is equidistant from 2 and 3, this 2.5. How about 3.5? Similarly, as was 2.5, 3.5 is just in between the integer 3 and 4. So 2.5 is equidistant from 2 and 3. Similarly, 3.5 is equidistant from two integers like 3 and 4. Alright, so for these cases where the value is where x is equally close to two integers, right? 2.5 is equally close to 2 and 3 because it is in the middle of 2 and 3. Similarly, 3.5 is equally close to two integers which are 3 and 4. It's 3.5. So in these cases, what RINT does is it will round it to the it will round to the nearest even number. Okay, RINT will round to the nearest even number because it has two integers close to it, equally close. Like 2.5 has 2 as well as 3. 3.5 has closest integer as 3 and 4. So what RINT does is it will prefer the even integer compared to the odd ones. So if you do math dot RINT of 2.5, right? So 2.5 you can go to 2 or 3, but we'll prefer even number. So that is 2. Similarly, when you're doing math dot RINT of 3.5, then here also it will go to the even, which is 4. Okay, so keep this thing in mind. I found this very interesting. Well, that's how RINT method has been written. Now in all these three methods that we have, you should look at the return type, right? So this is the return type. When your method is written in this way, we call this as a signature or a header of the method. Then the first information that we have is the return type. So the seal method also seals the double value to an integer, but it will return the double value of that integer. So if it is 3, it will return 3.0. It will not return 3.0. Similarly, floor will also return 2.0. It will return double, right? So seal, floor and RINT, they will return the integer value in double. Alright, so 2.0, it should be 2.0, and here also it should be 4.0. The value which is returned is in double, not in integer. Integer value returned in double representation. Okay, so now we have the final two methods which are the real rounding that we want to do. Okay, so it will not do seal or floor or RINT, it will do the real rounding that we know in mathematics, right? So if you have to round 2.5, it will give you 3. 3.5, it will give you 4 systematically. And interesting thing is that these two methods are going to return the value in integer. It will not have a decimal in the return type. Okay, so it depends. If you have the float value, then the output would be an integer type return. In case you have a double, then the output return would be long, which is an integer, but you know, extended or bigger version of integer, I should say, an integer where you can store really big integers. So that type is called long. And here it should not be difficult for you to follow. The point is that what we do when we have to compute the round value, what you do, you add 0.5 to whatever x it is, and then you do a floor on that, right? So if you add 0.5 and do a floor on x, then what you get is the real round that we are interested in, the rounding that we do in mathematics. So if you want, I can quickly do a demo on these. I don't need too much time. I can quickly run that, and I don't need any input from the user. Let me try math. M should be capital. Math dot seal. We learned seal. Dot seal of 0.001. Okay, but I should have some string to give us some idea like what are we doing. Seal method demo. All right, and let me copy it. 2, 3, 4. Okay, I think this should be fine. Let's do a demo for floor as well. Let's say LOR, sorry, and let me try 2.99999. Okay, and then I should do RINT1 demo, RINT2 demo. I should call RINT, and let's make it 2.5, and the second one I should do RINT with 3.5. I'm using the same example as I had in the lecture slide. Alright, and we should also try this round method. Round method 2.5. Should call this round. Okay, and then I'll try the same thing on 3.5 just to make sure that it is more consistent than our RINT. Round 1 demo, round 2 demo. Okay, so let's go. Alright, so seal, what is seal doing? Well, it is 2.001. I mean 2.0001, almost 2, but since you're calling it seal, so it will round up to 3. For floor, 2.99999, which is very close to 3, but being floor, it will return 2. RINT of 2.5 is 2. Well, right, as I explained, RINT of 3.5 is 4. Look at the round method, right? Okay, look at the round. So what round is doing? Round is kind of doing the same. It's fair to 2.5 as well as 3.5 because 2.5 has been rounded to 3. Similarly, 3.5 has been rounded to 4. Another thing that you should see right here is the kind of output which we are getting. So for the first 4 demo, we are getting the output as double 3.0, 2.0, 2.0, 4.0. Whereas for round method, you get the integer value. You don't get that decimal value. Okay, good. So let's go back and start from where I left. Okay, good. So I have some examples here also. There are some interesting examples like integer. So when it is -2 seal, well, you don't have any fractions, so the result has to be -2. When you have -2.1, then 2.1 -2.1 is less than -2, and you're sealing. right? So the next integer is -2. That's what you get. No surprise here. Floor. So when you have -2, no problem. -2 is what you get. When you want to floor -2.1, which is less than -2, but you have to float. That means you round it down to the next integer. So it should be -3 down. So the integer value which is less than -2 is -3. That's the reason you get the value as -3. So round -2.6 should give you -3. Okay, why? Because it's a value which is less than -2.5. Okay, so the next lower value in integer, that has to be -3. So please try these things and make sure that you understand. Now max and abs are fairly simple methods, but anyway, let's go over those. What max will do, if you are given two values like 2 and 3, it will return the maximum value. So call that with the name of the class math.max. Alright, so if you say math.max of 2 and 3, the result would be 3. Now if you have the values which are of different kind, like 2.5 is double and 3 is an integer, then what this method does, it will change 3 to the double, which is 3.0, and then, oh wait a second, sorry about that, I should be using my pen. Good. So this 3, oh sorry, not that one, this 3 needs to be changed to 3.0. Alright, so only when these two are in the same number representation, like both are in double, now you can return the maximum of these two. Similarly, you have minimum as well. Minimum will return minimum of the two arguments which are passed to it. Don't forget to include math.min, math.max. Similarly, we have the method absolute. A lot of times in mathematics mathematical computation, we don't want the sign. We are interested in using the magnitude of the number. So if the number is -2, we don't want sign for any reason. So we want to ignore the sign. If that is the case, you should be using ABS, which is for absolute. Math.abs, the -2 will return 2. Similarly, math.abs of -2.1 should be 2.1. The most important method now is the random method. Okay, alright, so let's see what do we have in random method. So random method generates random decimal values or random double values in the range from 0.0 till 1.0, but excluding 1.0. Alright, so this symbol that you have, which is the square bracket, which I believe is called an open, and then this parenthesis means closed. Closed means this range goes from 0.0 to 1.0, but you need to exclude 1, excluding 1. This is a problem. Excluding 1.0. Alright, so this is a very useful method because in a lot of cases where you have to randomly generate some data, you will have to call the random method. And interestingly, we can use the same value, which is 0.0 to 1.0, whatever random variables we are getting, and that can be translated to any other random data that we want. So I will do some demo, and using that demo I'll give you some tricks, like how can we exploit this random method to generate different kinds of random data. Alright, okay, so all these things that you see here, I'm going to do that in my demo. I'll come back and I will explain to you, like, what does these things mean. What would these things mean? Okay, discard the changes that I've done, and I don't want an input here. Alright, So what I'm about to do right now is that, well, I don't need scanner in this, right? So I'll delete these two things. Let's generate the some random values. So double rand val, because in the rand val I'll generate some random values. So how should I do that? Random value is rand val. There is a problem, I did not assign rand val to anything, but no problem, we'll do that. Okay, so how should I invoke this method? Rand val, I will invoke and assign the value to this variable that I just created, math dot random. Okay, good. So let's run that and try to see what kind of values I'm getting. Run that once. Okay, so it is in between 0 and 1. Keep running it, right? You will get all kinds of numbers. So what I should do, let me put that in a loop so that you can see some instances of this call. For int I equals 0, I is less than 10, I plus plus. Alright, and well, you need to know a little bit of loops right now, okay, because you have to finish probably a homework. So for loop is fine. The next chapter that we have would be on loops. Then you, after that, you will pretty much know about the loops, like how to use those. So now the way I have defined the for loop here, which starts with I is equal to 0, it goes till 10, I mean less than 10, I has to be less than 10, here starting from 0, and we have I plus plus, and inside the loop I'm just printing the random values. Well, okay, what should be the value? Think about it, okay, pause and think about it. Think about the values, like am I going to get different 10 values or not? Okay, I will run that. Pause and answer. Pause, wait, and then once you have the answer, then see what's the output. Interestingly, all the random values are same, they are not different. Why? Why are all the random numbers same? Well, the answer is right here. You call the random method only once and you save that on random val, and you're printing that 10 times, so you will see the same value. Instead, what I should have done, I should generate these numbers 10 times inside the for loop. Okay, so if you run that now 10 times, you should see all different numbers, mostly different, right? It will be very highly unlikely to see the same number. So same, all the numbers that I'm getting are double, and the range is in between 0 and 1. You'll be surprised to see that we have just one number which is less than 0.5. Okay, well, if you run that sufficient number of times, you'll get a good representation. Okay, so run that sufficient number of times, you'll get a very good representation. Now you will not see 1.0 because the range is from wait a second, from 0.0 to 1.0, but excluding 1.0. Okay, good. So now if you want to generate the number in a different range, what should you do? So there are a few things I can try here. If I multiply that by 10, then what will happen? Let's do that. Okay, so I will multiply that to 10 by 10. So what should happen? Now this decimal point that you see here would be shifted to right. Alright, so you will see 3.27, 4.41, that kind of a number. It will be still decimal, but it will be shifted right because I am doing the multiplication by 10. Let's run that. Okay, so you can see this change, 6.87, 2.5. Why? Because you are multiplying by 10. If you multiply by 100, you should see 2 digits on the left of the decimal. So that's the trick actually. We know the basic nature of the random method, that it generates the double random numbers from 0 0.0 to 1.0 excluding 1.0. We should know that fact, and then we should change it for in accordance with our need, which is not difficult. You just need to think a little bit, right? Think like a mathematician and you'll fix it. One more time, right? Yes. Now it's interesting to see like how can we change the program that I have right here to generate integers in the range from 0 to 10. Let's attempt that. Okay, so what we are getting is double. We need to change that into integers, and the range is fine, right? You are getting 4 0 1 2 5 2 0. So if I could discard, if I could throw everything that I have on the right hand side of the decimal along with the decimal point, then I'm done. I need to truncate. So how do we do that? Well, let's declare int rand int. Alright, and what will I do here? I should say rand int equals, let's cast this value to integer. How do we do that? Well, you should know. Alright, we went over that. Alright, and here we will print rand int. Let's see. Are we done? Yes. Look at it, right? So what I should be doing, let me take this print thing out, because I will generate a lot of numbers. So I will make it print, okay, no println, because println is adding a line. I want all the outputs on the same line, and I'm separating that with space. Let's run that. Okay, so the random integers that you got are 65492974338. You should not be happy with this result because it doesn't look like random at all, right? Probably we have higher numbers. We have 6 1 2 3 4 5. Well, okay, the point is, let's get more numbers. How about getting 50 integers? Alright, so see what happened. You got zeros, you're getting zeros, you're getting 9, but you're not getting a 10. Alright, so think about it. Why are we not getting 10? We are getting zeros, we are getting 9, but we are not getting 10. Reason being, here the range is from 0 0.0 to 1.0, excluding 1.0. So the maximum that you might get would be 0.99999, but never 1.0. So for that reason you are missing 10 here. So what's the trick? Multiply that by 11. Okay, well, think about it, right? Because I have got a lot of interesting suggestions from the student. Students say that we will add a 1, right? So students say that, sometimes they will say that you are not getting a 10. Okay, I have a solution. To whatever integers you are getting, add a 1. That's not a good solution, because, well, you will get 10. Let me run that. You will get 10. We got 10, right? We got a lot of 10s. But you will lose a 0. Because whatever you are getting, you are adding 1 to that, right? So you gain 10, but you lose 0. Alright, so this is not a good solution. So what's the good solution? Rather than adding 1, how about multiplying 11? Alright, so that's the solution. That's the answer. Did I get 10? Yes, I got 10. I got a 0 as well. So I'm very happy. Okay, I got more zeros. Oh, I got 10s as well. Alright, so I hope this thing is making sense to you. You need to think about it, and the hint is, I love this method, random. A lot of problems that I ask are framed around random methods. It's not only me, even in interviews you might find some questions which are framed around random methods. Okay, good. Fine. Now let me make you this problem slightly interesting. And I'll say fine, you could generate the numbers in the range from 0 to 10. Good. How about generating the numbers in the range from -5 to +5? Okay, -5 to +5. How do you do that? Well, for that thing to happen, we need to play here a little bit. Right, so how should we play? Let's add -5 plus will that help? We need to think about it, right? Probably not. Okay, let's try that. Okay, if you run this, what are we getting? Are we getting 5? Yes, we got 5. Are we getting -5? -5, -5. For -5, if you get a 0 here, then you should get a -5. Do we get 6? No. If we are not getting 6, then that means we are okay. But we should get a -5 also, and I'm sure that we should get -5 because if you get the math.random as 0, then -5 if you add to 0 should give you -5. I'm surprised why we don't have -5 here. Let's run that one more time. We are getting -4, -5. Where is -5? Okay, I would love to see your response to this thing, right? Take it as a bug in my program, work on it, and tell me like what was missing in my program. Alright, so if I say 10, okay, let's see what will we get. Am I getting -5 here? Well, I'm not getting a -5 even now. Anyway, we'll get back to that. Okay, I'll get back to that, and I might post a solution online as well. Alright, so let's move on. Wait a second, there is a problem. -5 into 11, you have that. Alright, please work on that. Okay, I'll be happy to see your solutions. There's one bug in my program which is not letting me get -5. I should get -5. Conceptually, I think I'm good. Let me run this for maybe 100 times. Okay, -5 plus -4, -4, -4. I do get 5, but I am not getting -5. Alright, so I need to fix that, but let's go back to the lecture slides. Alright, so here we have it. In this slide you will see every discussion that I made in more systematic way, in more general way. So what does it say? It says that the random method generates a random double value which is greater than or equal to 0.0 but is less than 1.0. So math.random will get you all the values from 0 including 0 till 1, but 1 is not included. So if you multiply this result by 10 and find its integer, right, then it will return the value in the range from 0 to 9. And if you add 50 to that, right, so we have a different example right here. So here we want to generate the numbers between 50 and 99, because the lowest 0 that you have, you're adding 50 to that, right? So the range will be shifted from 50 to 99. Okay, so that's another example which will help you in generating random number in a range. Alright, so here if you want to map that to the problem that I was doing towards the end, if you do -5, so that's your lowest range, and then you multiply mat.random with a number, do its int, and then you get the corresponding range. So in general, if you have to generate the random number which starts with a and goes till a plus b, then that's what you do. It will return a, because mat.random can give you 0 also, and maximum that mat.random will get you is b excluding b, right? So a plus b would be excluded if you do it that way. If you want b as well, if you want to generate the number in the range a to a plus b, then here you should do a plus mat.random multiplied by b plus 1. Alright, then you will get the numbers in the range from a to a plus b. Alright, so I think I explained everything to you using that example. Let's move on to the next interesting thing, which is characters. So characters are interesting data types which we will use in a lot of cases, and it's important for us to understand characters, because strings which are very common data types are composed of characters. So if you have a good understanding of characters, then it will help you in solving some problems on strings. Okay, so how do we represent a character value? So character value, is represented using single quotation. So if you have a value or a literal a which you want to assign to a character variable, then that's how you should be doing. Character, char, letter s is equal to capital A in single quotation. So that means you have a character literal. When it's a character literal, only when you put that in the single quotation. This is a single quotation, okay? Yeah. So now there's something called as ASCII. I will explain that to you later. So let's look at some examples, and whenever I need to explain, I will explain that thing to you. So this is an example, first one, where you have a variable called letter, its type is character, and to that variable you are assigning a character literal. In the second case also, well, if I tell you 4, right, so this is an interesting example. If I just say 4, then this is an integer, but if I put a quotation, single quotation around it, then it becomes a character. It's a character type. Just 4 is int. It's an int literal. Okay, so these are some literal examples, literals, which are values which you might assign to a variable. So 4, if you don't have any quotations around it, is a simple integer, but if you put single quotation around it, it becomes a character. And if you go on and put double quotations around it, then it becomes a string literal. Alright, and it's an interesting string literal, the last one, because this string has just one character. That's fine. You can have an empty string also which will have nothing in there. Okay, so interesting. So here the variable is num character, numchar is the name that you have given to the variable. Its type is char, and you are assigning the value 4, literal 4, to the numchar character. Alright, now is the time that I should explain to you this concept of ASCII. What is ASCII? And once you know the ASCII thing, then you will follow the Unicode as well. So as I mentioned to you in the beginning of this course, that the computer understands, or the computer hardware understands just binary things, zeros and ones. That's the thing our computer understands as it goes to the hardware. So all the information that we have, which we want to store, is stored in zeros and ones. Okay, so every character that you see on your keyboard has a value assigned to it. Alright, so let me write this. Every character has an integer to value assigned. To it. and this value assignment is called, this is called coding or encoding. Oh, uh, let's call that coding, Unicode or coding. Okay, so this is called coding, and there are some standards which are used to assign this integer value to the characters that we have on the keyboard. All right, so one of the coding scheme is called ASCII. All right, and the second one that we have is Unicode. So ASCII is something which people refer very often, because in early languages like C, ASCII was used for encoding. But with with Java, we have moved on to a different encoding approach that is called Unicode, and Unicode has the capability of encoding more characters than what ASCII had. All right, but the interesting thing is that the ASCII is a subset of Unicode, so, or Unicode is a superset of ASCII, so the values for most of the character remains the same in ASCII as well as the Unicode. Okay, so if you are interested in knowing, then I can write this. All right, let me erase this because I need some space. All right, so ASCII stands for American Standard Code, ASC, for information interchange. So ASCII is very standard, so I thought I should tell you the full form of ASCII, American Standard Code for Information Interchange. Now we should know, like, what I mean, we should not remember these coding which have been assigned to different characters, but I will do some experiments which will help you understand like what code corresponds to a letter. Alright, so in Unicode representation, there is this hexadecimal encoding for every character. Alright, so this value that you have, which is being put in the single quotation followed by /u, means that this is the Unicode code for a letter. Alright, so let me do this exercise as a demo, and then you will follow what we have here. I will discard because there's a lot of clutter on this slide. Okay, so we will revisit to this example. Maybe in my next video lecture I'll do that. So char my character. Now what can happen is I know the value for one of the character. Alright, and let me put that out. Character. Okay, let's see. A. Right, so what did I get? This 65 integer value that you have is the ASCII and Unicode code for letter A. Alright, so what we are learning about the code for every character that we have. Alright, so with this simple example, what I did, in the variable which is my char, its type is a character, but in place of assigning in place of doing something like this, right, which we normally would do, what I did was I gave the code for that, right? So let me run this thing. No surprise, we were expecting an A. What I did instead was I put the code for that, which is 65. Now, well, 65 is a number which is very common, and letter capital A is so common that over the years I somehow remember this value, but you are not supposed to remember these values. And for a lot of problems on character, you can solve this issue without even knowing the code, right? So don't attempt to memorize the ASCII or Unicode value for different characters, there is a trick. You will get those values if needed. Okay, good, right? So here I was assigning the ASCII code in decimal. You can pretty much use the Unicode representation, and in the Unicode representation we use single quotation and /u for Unicode, and the numbers that you have is in hexadecimal, right? So I uploaded the video lecture on number systems. I hope you followed that and you understand different number systems. If not, let me know. 0041, again this is something I remember from my lecture slides. Okay, so 65 that you have, you can write that as 41 in hexadecimal, and Unicode is in hexadecimal, and that you communicate to the compiler by putting this value in the single quotation, and then before the value you will have a backslash and u for Unicode. Let's run this thing. No surprise, you got an A. Okay, so we have another example. I don't remember the character 34, so let me take this value from here and put that 34. Now if you want to know what is the decimal corresponding to 34, then we need to compute 48 plus 4, so it will be 52, but I don't know what character do we have there. We don't need to remember also. If you run this program, you will get the value 4. Okay, so 4, this 4 is not integer 4, this is character 4. Alright, so this 4 character that you have, its Unicode value is 34 in hexadecimal. It's not in decimal, it is in hexadecimal. Alright, so did I miss anything out? No, I did not. Yeah, 4, right? So this 4 is same as 0034, which is in Unicode. Alright, let me tell you a few other interesting things that you can try, which will be very handy in your programs as well. If you don't know any code, right? If you don't know any code of a character, then what should you do? Just declare a variable of type integer, right? So what I'm doing, I'm calling, okay, you know what, code is my integer variable, in which I'll get the ASCII code or the Unicode for the letters that I have. So what should I do in single quotation? I should put the character. I don't know the ASCII code of star, right? So what I'll do, if I assign the character star to an integer variable, then the output that I get will be as, let's call that ASCII, okay? ASCII. Code is now CODE. Alright, so 42 is the ASCII code for star. You want to double check that? Let's put A. I know the value of A, 65, right? Small a, it should be some 92, 97. Alright, so that's the trick. Assign the character literal to an integer variable, and if you print it out, you will get the corresponding code. Okay, good. So now let's move on and see what else do we have. Well, it is possible to do the increment operator on the character, because for the reason that if you see, like, how do we represent okay, let me run that, right? So it will make a lot of sense to you. 97. If I say ASCII code of next character is code plus plus. Alright, let's see. 98. What did I do? See, what I'm trying to tell you is that since characters are represented using numeric code, and you can do the operations of the numeric code. Similarly, you can do some operation on characters as well. So what I did, I'm just updating the code. What is code? Code is the ASCII value. And what's that ASCII value? 97. 97 is the ASCII value of A, right? So what did I do on line number 6? I changed the code value to 98, right? And that's what I'm printing out. So if you want to get the character at that position, then what you can do, next character is let's cast that, right? CHER, because you know the code now. The new code is 98. So if you want to get the character with the value 98 as its ASCII, then you'll get the corresponding character, which should be a lowercase b. Alright, so I hope this is making sense to you. The message is that since the characters are represented as integer by different coding styles, so if you do the character plus plus, alright, then what will happen, it will go to the next code, and the next code will give you the next character. Alright, so to make it simple, I hope these things are making sense. If not, then please let me know. Let's do this thing directly. Okay, the next character is, I will have to change this. My char is A. Alright, so here I should say plus plus my char. What did I do? Well, I have a character which is A, lowercase a, literal lowercase a in my char. I'm just doing plus plus to that. Plus plus means I'm incrementing 1 to the character. So can I do that? Yes, you can do that. Why? Because every character is represented by a number. So what should I get? B. You got it, B. Alright, so that's what you have in the next slide. Okay, so the increment and decrement operator can also be used for on a char variable to get the next or the preceding character. Now Unicode character, for example. Alright, so if you, the same thing, right? What I did, you will find right here as well. If ch is an A, you try to do plus plus ch, what you get is the character B. Good. So now you need to understand this thing that Unicode is 16-bit encoding, whereas the ASCII is 8 bits encoding. So you know, since we have 16 bits, double the size of 8-bit, so with Unicode we can represent the more characters compared to what we can do with ASCII. So why Java moved to Unicode? The reason being that we wanted to represent even more characters than what we can represent using ASCII. So that was the need when why Unicode encoding was followed for Java characters. Now how do we represent Unicode? For that you have to use a backslash followed by a U, and then the next 4 digits that you have are for hexadecimal. So you have all the range possible from 0000, which refers to 0, then to the highest positive value, which is 65535 plus 1. Alright, and that in Unicode is \U FFFF. Okay, fine. So now if you are interested in knowing the values, just for your curiosity, or if you are trying the experiment that I kind of gave you, where you can get the ASCII code for any character that you have on the board, you can double check these values. So the characters, the numeric character that you have from 0 to 9, their ASCII value, and which should be the Unicode value as well, ranges from 48 to 57. So 0 means 48, 57 means 9. And these are all, stored consecutively, I mean next to each other. So this fact is very useful when you write a program to check whether the character is numeric character or not. What you need to do is just check whether the ASCII value or the Unicode value that you have for the character lies in this range or not. Alright, so you will just check this thing, right? Assuming that not int, it should not be an int. Okay, let me erase that. First of all, I want to change the color. Erase. Okay, sorry. Pen. Alright, so if you have a variable which is declared as char mychar, in that mychar you got some value, right? So say we have the value as lowercase z, and you want to check, right, whether z is numeric or not. So what should you check? Well, you will have to just check this thing, right? If mychar is greater than or equal to 48, right? So either use 48 or use 0. I prefer using this thing, because don't try to memorize 48, right? In place of 48, if you use literal 0, you are good. If mychar is greater than or equal to 0 and mychar is less than or equal to 9, if that is the case, then you should say that system dot out dot println what numeric character. Alright, it's so simple. You need to compare the character variable which we have assigned as z. It could be anything. You can get this value from user as well. You need to check whether that value of the character lies in this range or not, right? Is greater than or equal to 0 and less than or equal to 9 or not. The same logic you can apply to check whether the character is the uppercase A on uppercase alphabetical character or not. Similarly for lowercase or not. And these values, if you are really interested in knowing, and then a capital A is 65, we just saw that, and capital Z or the uppercase Z is 90, lowercase a is 97, and the uppercase Z is 122. Well, if you are interested in knowing their Unicode value, then just convert that into a hexadecimal and you will get that, right? 16 3 times is 48. Similarly these things, right? Okay, good. So alright, now we have some characters which are called escape sequences. Escape sequences are some characters which behave differently. Like if you want to add if you want to use backspace character, you can use that as /b. So escape sequences are always followed by backslash and then whatever special character you have. So if you have escape sequence, you should be writing as /b. If you want tab, you should write that as /t. /n is for new line. /t is for adding one tab in your in your text or string, whatever. So tab character, right? So you do have tab character in your keyboard. If you want to capture that, then you should have /t. /n is for new line, /m is for form field, so on and so forth. The very interesting thing is the case of double quotation. If you check your keyboard, you'll find this as well there. Now if you want this character to be represented in your string or as a character itself, you cannot use just the simple double quotation. You will have to use that with the backslash. Okay, so these together will define the escape sequence double quote. Alright, so now if you want to look at the ASCII code for these different characters which we have right here, then it's easy to look for that on this ASCII table. As an example, if you want to find out for capital H, then its ASCII code is go to its row number, which is 7, and then look at the column number, which is 272 is the ASCII code for H. Similarly for A, row number 6 and column number 5, 65. Alright, so this is how you can look at the ASCII values for different characters. The same is being continued, but now we have in the Unicode, right? So the values that you see here is in Unicode. As for A, if you are interested in finding out, it will be 41, but this 41 is in Unicode, that means in hexadecimal. You need to convert that back to decimal to understand that. Well, these two tables are not to be memorized. You just need to understand, like, how do you get the values. Now, to this point, as I was saying, telling you that this random method that we have is very useful. So we tried to generate some random values, like I tried to generate random integers from 0 to 10, 0 to 9. We succeeded in doing that. Now, interesting thing is that you can use the same random method to generate random characters as well. Okay, so for some reason, if you have to generate characters from A to Z randomly, then you can make use of the random method, math.random. And how do we do that? Here is the approach. Alright, so what is this? If you see, say int and then cast the character literal A to int, then you get the value, which is 97, I believe. Let me double check, okay? A is 97. Yes, we are right, 97. But you don't need to remember because we are not using 97. I'm just explaining to you like what will happen. So you need to convert that code to character. So we will get back to character later. What we need is that since we need to generate all the characters, let me write that here, starting from A to Z. Alright, so this is open, that means A included, open means Z included. So you need to start from the lower range is an A and its ASCII value. We'll use math.random, which will naturally give me a value in the range 0 to 1, 1 closed. That means I will not get 1. So I need to fix that thing that I get 1. Now what we have to do, we need to think about the Z, like how do we get the ASCII value of Z. So for that, what we are doing, to whatever ASCII value that you have from A, because we need to start with A, then B, then C and E till Z, but that is to be done randomly. So how will we do that? Let's think about this range that we get. Alright, because if you multiply this range to math.random, then only you'll get something interesting. If you do not multiply this, then you know that it will be useless, because we'll get 0 to 1. So most of the times you'll print A only, all the times you'll print A. So here we are finding that out, right? So how do we find out? Get the code for Z, right? If you want to get the code for Z, we can do that here itself. Z is right here, so it is 122. 125, this is 12 and this is 2, 122 for Z. Alright, so this is 122 minus 97, okay, and then plus 1. So this is the range which will help you in getting the next 25 characters. Alright, so if you spend some time think about this logic, then you'll figure out that this is how we can easily use math.random to generate all the characters randomly from A to Z. This is the lowercase a, and the lowercase z. Alright, so please do this experiment. I mean, it will encourage you a lot, and that way you will learn. You might get some errors, some compiler errors or bugs, but don't worry about that. Programming means a lot of errors initially. Okay, so please practice that, and I'm sure you'll feel a lot better. So what you will get here, if you're just looking at the value inside this parenthesis, the outermost, then this will be ASCII or Unicode value, which is an integer, which will be an integer value. Now, since you want to find out the character that corresponds to this value, so you will have to cast that character. Alright, and after casting that, you'll get the appropriate character. Alright, so this is a very interesting application of math.random method, and your knowledge of the ASCII codes, like how can we exploit that. Okay, so now here I have one of the most important slide, I'll say, which gives you some idea about how to check a character, whether that character is uppercase letter or not, lowercase or not, is numeric character or not. So what you have to do, if ch is your variable, ch is your character variable, then what do? Just compare that for the range. Check whether this is greater than or equal to a, and at the same time less than or equal to z or not. Right? So if you do that, you'll check whether it's an uppercase character or not. And if you have a smaller, if you change the range to small a and small z, that way you'll check whether the character is lowercase or not. And if you change the range to 0 and 9, then you can check whether the character that you're checking belongs to the numeric character or not. Alright, so interestingly, we have the methods available for these things that I'm explaining. You can check whether a character is a digit or not by just calling this isDigit method, but there is a trick. If you have to call isDigit, then you should do that like character dot isDigit, and then you can check like 2. This is my number 2. Okay, yeah. But I discourage my students in trying these methods, because since you are learning programming, I would like you to write your own program, because writing this is not complicated, and this is how I will check whether you understand programming or not. Alright, so it's good to know that these methods exist, but I would encourage you to write your own program that corresponds to these logics right here. So is character.isDigit, you can check whether the character is digit or not. Similarly, you can check whether the character is a letter or not, letter or digit, whether it is uppercase, whether it is lowercase. You can change that to lowercase, you can change that to uppercase. But for all these methods, the key is that you should do that with character period, the method. Alright, then, well, I planned to cover the strings as well in this video lecture, but it will be a very lengthy lecture. So what I will do the string part in my next video lecture. Before we go, I would like to try this random character thing, because this is interesting. Alright, so what we have to do, let's write alright, let me generate my randChar, because I want to generate the character randomly. So how should we do that? Well, my randChar is equal to will come. Okay, we should know these things, right? Anyway, whatever we get, we need to cast that into the character, because what I will have inside these parentheses would be the ASCII values, right? So how do I get those ASCII values? Well, let's start with A, right? Because I want to generate all the random random characters starting from lowercase a. So that's my lower range, A. And how do I take care of the randomness? For that I need math dot random. Okay, and let me multiply math.random with the range so that I may know like what is the extent of the ASCII code that I should generate, right? So from this knowledge, you know that there are 26 characters, but let's not hard code that, right? This is called hard coding. I will explain to you like what hard coding is later, but for the timing, let's make it as general as possible. So what do we do? Well, we need to generate all the characters, right? So we need to find out the range z. We should know the ASCII value of z. We don't need to remember, but yeah, we will get that if I put z in the single quotation minus a. Alright, and I will also need a 1 here. Alright, why 1? If I ignore 1, then because of the fact that math.random would not generate 1, right, I'll be in trouble. Alright, so for that reason what I have to do is I need to include plus 1 also. Okay, so here if you pay attention to z minus a, so since there are there are 26 letters, and if you remember z was wait a second, let me do this simple calculation, although this is not difficult but it helps. I'll use the calculator. 122 was the ASCII value. I somehow remember, you don't need to remember, minus 97. So 122 is for Z and 97 is for A. So if you divide, then you are getting only 25, and there are 26 characters, right? So if you multiply math.random to 25, the maximum value that you get would be 24. So from A, if you get from A, you'll be able to get the next 24 characters, which will take care of A to Y, but you will never get a Z, right? So just to get the Z as well, you need to add 1. Because if you have 25, which you are getting after subtracting ASCII value of Z, which is 122, minus the ASCII value of A, which is 97, you get 25. And since you are multiplying that to math.random, the maximum that you get would be something less than 1, right? So you will only be able to reach Y, you will not get to Z. So for that reason, we have to add 1 as well. Alright, now we are good. Okay, I think we are not good yet. What you should be doing, you need to cast that into integer. Alright, and let's print this out now. 6 out my rand cat. You got an A. Let's run that again. We're getting an A only. Wait a second. I think we are missing something. What is it? Okay, good. Probably that's the problem. Alright, so we need to be very careful about these cases. U, S, I'm getting all these things. So what I should do here, please pay attention, right? What I did not cast the whole expression. How should I cast the whole expression? By including everything in a parenthesis, right? Now only this guy is casting the whole expression. Otherwise, the result was only the math.random was getting casted to 0, and the result was an A. Okay, so you see these bugs, it's very common. So for int I equals 0, I is less than 50, I plus plus. Let's generate 50 random characters, because I'm confident that we'll be able to see at least the extreme. I'm more interested in getting A and Z. Okay, so here I'm not putting new line because I want all these things in one line itself. So I added some space. Alright, let's run this. Okay, so did you get Z? I got Z. Did I get an A? Oh, well, yes, I got an A as well. I got A and I got Z. So this is giving me the hint that yes, I'm generating the random numbers. Try that multiple times. Okay, so this will change. So here also, did I get a Z? Did I get an A? Uh-oh, I have a Z, but you may not get that, right? It's a random thing, so you may or may not. In my first trial I was successful. I got A and Z as well. I was lucky, I should say. So here I'm getting a Z. I got an A as well, right? Yeah, good. So let me stop right here. And this was intense because a lot of interesting thing we discussed. And the next lecture, which is about to come, it is on strings, is even more interesting. So please do all these exercises. I'll see you in the well, wait a second, let's not leave. Let me give you this demo as well. So this is about using the existing character methods is equal to S, right? So I should say character dot is letter. All right. Okay. So that's how you have to use it, right? With the name of the class, character class, because this is defined in character class. True, right? Why? Because this is this is a letter. If I change S by 9, right, so you should get what? A false, because this is not a letter, this is a numeric character, right? So you'll have some corresponding is digit, right? So if you try is digit, then it should give you true. All right, and now just for the experiment, if I remove character, then see, you're getting an error. But this is undefined. So since it is defined in character class, and this is what? This is static as well. Is digit is a static. That's the reason you're using the name of the class, which is character. All right, good. So now let me stop right here. I will see you in the next video lecture where we will cover the string class. All right, please do all those exercises that I mentioned, and yeah, these are all very important. Thank you so much. Yeah, see you in the next video lecture.